In this video, we're going to continue with creating the character controller here. Now we're going to use a state machine for this one. I know that I based this tutorial on someone else's tutorial, and then I've made it my own with the state machine, and now I'm going to modify it again. So I can't remember what the original one was. I suspect it was Heartbeast's 1-bit platformer maybe. I can't remember now. But here's some really good tutorials, but there is one tutorial that frustrates me because he seems to waste a whole lot of time in the second video doing tilings when he's using an auto tile, and then later on about video 6 actually uses the auto tile. It just seems like he's wasting time setting up something that is inefficient and doesn't get used. We are going to use the auto tile for this here. I don't mean to diss Heartbeast. He is really good at this stuff. And like I said, some of this was based on his, but it's so far removed from that now that I would pretty much call it my own. And let's go ahead. So we're going to go into here, and at the top, and I might just make this, I can't really make it bigger because then it'll be really frustrating for me. So hopefully you can read this code. I'll just see if I can make it a little bit bigger. The editor, where's the editor? That's the game settings. Editor settings. See, main font size, code font size. Ooh, I must have turned that down. So let's go. Yeah, that's better. Okay, so we're going to put in a few variables. Now these exports are going to make them so that the variables appear on the right over here. And go int speed, and I'm going to set this to 120. Int var jump speed equals negative 180. I don't remember where I got these values from. Probably trial and error. Gravity equals 400, and then export int var slide speed, which we may not end up using, equals 400. So what I'm doing here, export is going to make it so that, and I'll just show you what I mean. If I click on the player, if I click on the world and I click on the player, these variables show up here. So I can actually change them in here very quickly to test things in my game. If I want to change the gravity very quickly, I can just click on the player and change it here. So these have preference over what is actually written in the code. So if in the code I type, you'll see here, I change this to 500, and in the code I change this to 200, and go back to here, click on the player, it's still set to 500, but if I hit this little reset button, it'll go back to 200. So whatever's written here has preference over what's written in the code. So we've got those there. I'm going to have a variable called velocity. This is going to control our movement. And at the start of the game, it's going to be set to 0. There's a few ways to write vector 2s, but I could write it like this, or I could write it like this. The vector 2.0 is just an enumerator that refers to what I just did before with 0, 0. So a vector 2 contains two positions, x and y, and we are going to use vectors or directional vectors to say which direction the player is moving in, whether they're moving down, left, right, etc., and work with that. We are also going to have, and I don't remember if I used this, but let's throw it in anyway, friction and acceleration. And we're going to create some states. Now, a lot of people do states with text, and I probably could as well, but I do like the way the enumerators work. So we're going to have some of these states in here. Jump, fall, and attack. There's probably other animations that we'll add at some stage as well, like the dying animation, etc., getting hit, and so on. But these are going to be the main states that the player can be in. And then we'll have an onReady var player state equals state.idle. Now what this onReady does is it waits until the game is ready to go and then it sets the variable. So it kind of holds it in memory. It goes through when it loads and sets all these up. Some of them it sets up before it loads, as it puts them into here. And then onReady is pretty much just doing it in here, except if we did it in there, the player state variable would only be usable in the ready function, but we want it to be usable by the rest of the code as well. So what we need to do here is I'm going to make a few functions. One of these functions is going to be called update animation. And we'll say anim. And this is going to be really simple. It's just going to be animation player dot play anim. We could probably make this a bit more efficient, such as saying if the animation exists, then we'll play it. Otherwise, we'll get an error. But we're not going to make that a problem, and we'll just make it simple. And then func handle state. And we'll just write pass in here for now, because we will come back and write some more of this code later. And then we're going to have the main function, which is going to be the physics underscore process and delta. Now this is built in, and if I hold control and click on it, it actually shows up. It says it's called during the physics processing step of the main loop. Physics processing means that the frame rate is synced to the physics. Delta should be constant. Okay, because we're using physics, we're using kinematic bodies, we're going to be moving things using the physics system. We want it to be synced to the physics instead of just running as fast as possible. Okay, so in here, we are going to put in some checks. We're going to get the input from the player, and we actually need a function to handle this as well. Func get input. So the first thing we're going to do in here is we're going to get the input. So we should probably write this code here. And I have written it over here, but I'll probably change it slightly. So let me just bring it up. We're going to say here, let's see. Yep. We're going to make a temporary variable called direction. It's going to equal input dot get action strength, and I'm going to say right. Now that doesn't exist at the moment, but we're going to subtract it from input dot get action strength left. Now this would be a good time to actually explain how the input system works in here, and I'll do that. We'll go up here, project settings, and input map. So we've got these that are the default ones, but we're going to add one called right and add one called left. They show up at the bottom here, and if you click on one and hit the plus button, you can add a key to it. So for the right key, I'm going to add the D key, and I'm also going to add the right arrow key. So either of those keys will be able to be used for right, and for the left, I'll add the A key and the left arrow key. So these are now going to check those things here. And what get action strength will do is, if we were using a gamepad, you know, I've got a gamepad here actually. So if we are pushing all the way to the left, I think my thing is reversed, all the way to the left, then what would happen is that would register as a 1. But if we were not pushing anywhere, it would register as a 0. If we're pushing a little bit, it might be like 0.5, something like that. However, on the keyboard, it's only going to be 0 or 1. So the way this works out is, if we're pushing the right keyboard, the right key, then it's going to be registering as 1. And if we're not pushing the left key, this will register as 0. So it's going to be 1 minus 0. And that will be our direction. Our direction will be 1. But if we're pushing the left key and not the right key, this will be 0. It'll say 0 minus 1, and that'll be negative 1. So our direction will be negative 1. If we're pushing no keys at 0 minus 0, which is 0, So our direction is 0. And if we're pushing both keys for some reason, which you can't do on a gamepad, you can't hold both directions at the same time, but you can hold both keys at the same time, especially on a mechanical keyboard, it will be 1 minus 1, which is 0. So again, we will get a direction of 0. Then I'm going to set some velocity stuff here. So if the direction is not equal to 0, we're going to say velocity.x equals move toward velocity.x direction times speed acceleration. Now, what does this code do here? Let's look at this. I'll write the second half in as well, because you might be able to figure this out. Else velocity.x equals move toward, and we're going to move velocity.x towards 0 by friction. So what I just said then might not make sense to you, but this is a special function in Godot that lets you calculate it's like, I'm just trying to think of how to explain it. You've got a value and a target value. So we've got our current velocity, whatever that might be, the x value of it, and we want to either move it towards our maximum speed, or we want to move it towards 0 if we're not pushing anything. So if the direction is equal to 0, we want to move our velocity towards 0 by this amount. So what move toward does is it says, well, give me the value that you want to calculate. That's velocity.x. What's the target value? That's 0 in this case. And how much do you want to change it by each frame? Well, that's the friction. Accelerating is different though. We want it to move towards the speed, so the speed the player moves at, by the acceleration amount. And so every frame it's going to move towards the speed that we want it to move at by the acceleration amount. And that's how this works here. So this is the input, and then we are checking that, getting the player's input, updating it, and that's updating the velocity, which we'll use shortly. All right, so back into here. We're going to say if velocity.x equals 0, then we're going to set the player's state. Player state equals state.idle. Now, this is not going to work that well at the moment, because if they're falling, the x might still be 0, and they won't go anywhere, or they won't actually have the falling animation. But we can change this later. Okay, so we're going to have in another one here, elif velocity.x. We could just say, actually, if velocity equals velocity.0. Sorry, vector 2.0 with a capital V. There we go. So if velocity is equal to vector 2.0, then we know they're not moving anywhere, and they are in the idle state. So that's all good for now. If velocity.x is not equal to 0, and we can say get action strength, or input.get action strength. So now this is where my code is deviating from the one that I had done before, because I had rolling and stuff in there, which I'm not going to do just yet. We're going to put the jump in here, and is on floor. Now, is on floor is a built-in thing in Godot that will check to see if an object is on floor. Now, why is this giving me an error? Elif velocity is not equal to 0, and get is greater than. Oh, I'll change this here instead of that. Is action just pressed? Jump. And is on floor. Let's type pass for now. Cool. We're going to go up here and project settings, input map, jump, add that. I really hate up as jump, so I'm going to put it in as space. If you want to put it in as up, you can. We're not going to be climbing ladders or anything, so It's up to you. I'll put it in as up as well. But I do hate it. Okay, so we've got that there. Then we're going to make it player state equals state dot jump. So what we're doing here is we're setting all these potential states, and then at the end of it, we're going to run this handle state function, which will go through and actually handle the player state. So let's go ahead and go elif velocity dot x is not equal to 0. We'll say player state equals state dot running, like that. So these here are all going to have preference. So if we're jumping, then that is going to take preference over the running bit there as well. I'm going to go down a little bit here. If not is on floor. So this is another way of saying if is on floor equals false. So you could do that as well. If is on floor equals false. That's the same thing. Prefer to write this way. So if they're not on the floor, if velocity dot y is less than 0, we're going to say state dot jump. We're going to have to add another state here, I just realized. So we're going to have jump and start jump. And this one here is going to be start jump, because we're going to use this to manage what happens. Jump is fine. And if velocity dot y is greater than 0, player state should be player state equals state dot fall. Player state equals state dot jump, state dot fall. That's all good. And then finally, we need to set the gravity. So I'm just going to put some code here. Set gravity. That is a comment. Velocity dot y plus equals gravity multiplied by delta, and then velocity equals, and this is where we apply the movement. Without this bit of code, none of it's going to work. This is the physics movement code. Velocity vector 2 dot up. So what's happening here is we have got the x velocity being set by our get input, so left and right keys. Then we need to, when we do the jump, start jump function will get run, and we will actually apply some stuff in here. So I'm going to do something here, which is going to be handle state. We'll call that function. Send the player state to it, and then update animation. We'll call that there, and we'll send the player state to that. That's not going to work, so we're just going to type pass on that one for now. Make sure you change that at the top. So animation's not going to work when we test this in a minute, but this video is getting a little bit long, so I just want to finish it and make sure that it's all working. And so what's happening down here is then we apply the y velocity, which is going down, and we're going to add gravity multiplied by delta. The reason that we have to multiply it by delta is otherwise every single physics frame, which is about 60 frames a second, we could turn it up to 240, but every single physics frame, we're going to be adding 400 units. However, this will tell us the time between frames, and we can multiply by it, so it's going to be like 0.01 or something like that, and it'll slowly add the gravity. Still fast, but much slower. Then we do the move and slide, which will apply the velocity vector to our object. So I'm going to open up Paint and try and draw this. So we've got bad, I can use lines surely. Okay, so we've got our X and Y. So X and Y. And then, say if we're pushing the right key, it's going to be saying, okay, our vector2 is, well, velocity.x, and if this is our velocity here, the x and the y, and it's a vector 2, so it actually has two values. This is going to be 1. And let's say we've applied some gravity to it. So the gravity, maybe it hasn't fully applied it, so it's only about here. So it's like 0.5, negative 0.5. It'll be negative 0.5. I can't remember. I'm pretty sure that Godot uses simple screen space coordinates, which would mean that y is actually positive going down, so not negative 0.5. But then this is going to be the vector that's applied to it. So the next frame, our object is going to move along this vector. So in this case, 1.5, it's going to be kind of like moving at like this vector here. You do a lot of stuff with vectors in physics, I think. So if you understand vectors, this will make sense. If not, just trust me, it works. And let's go ahead and test this. Actually, we can't yet. We need to put in another collision object. So I'm just going to put a collision shape in. And I'm going to make this one a rectangle. It's up here. I'm going to move it down below our player. Just make it like that. All good. And then I'm going to go debug visible collision shapes, so we can actually see whether our player's colliding. Hit play scene, and this should be the first time we've probably run anything now, and our player just fell straight through. Why? Collision shape. Oh, okay, I can't just add a collision shape, of course. I need to have a static body, and then I'll drag the collision shape onto that. So I've got static body with a collision shape on it. The collision shape by itself does nothing. It just gives a shape to a physics object, which is why I just fell through it. There we go. So I can move left and right. It's just got the idle animation playing there. Up does nothing, space does nothing. But let's test that it's working. So we can go into here, and in update animation, I'm going to print. We'll do it in here, actually, handle state, print state. Okay, so we're going to print what gets passed to it, which should be the player state. So down the bottom here, it's just going to have 0, 1. And it did jump, but it only jumped. Oh, there's an error here. Okay. This one here, we're going to just get rid of this velocity.x is not equal to 0 because we don't need to be moving to jump. elif, input action, just press jump, and we're on the floor. It's not actually working. And there is a funny reason for this here. And we may need to make some modifications to this code to get it to work. What I'm going to do is I'm just going to print is on floor right here. If this says true and false a whole lot down the bottom, this is a big problem in Godot. It says true a whole lot. Well, that's good. Okay. All right. I suspect I know what's gone wrong then. If velocity equals vector2.0. Okay. All right. We'll fix this in the next one, but I probably just need to get rid of some of these here. And that should work. Yeah, there we go. You can't really see it, but when I push space, the number 5 flashes through there. Now, the reason it's not printing the actual state name is because these just refer to numbers. So 0, 1, 2, 3, 4, 5. So start jump actually worked. I should be able to test fall. So I should be able to fall off the edge, and it should give me a free fall. Yeah, there we go. 6, which is set to fall. Cool. So in the next video, we'll look at adding those animations in and making our character jump.